Okay, welcome once more. Today we have reached chapter 10, where we're going to be talking about peripheral devices. As we've mentioned earlier, they're basically all those devices that we connect to our computer externally to give our PC some certain capabilities, which they are not capable of by default. I want to believe that you guys can hear me properly and everything is going on well. Can you hear me properly, Mariam? Mariam,
Yeah, I can hear you.
all right. If you're not hearing or at some point there is a complication and you can't talk, you can even just type. I'll see the message.
Okay.
All right, great. So now we're talking about uh, in peripheral devices, and they are just these devices that you plug externally to a computer to give some specific functionalities, which the PC is not capable of by default. So we are going to be using most of these terms as we go through this chapter, which include digitizers, input device, input and output or I/O devices, KVM, KVM switch, lumen, near field communication and output device. So what are the definitions of these concepts? We must be wondering. Let's look at them. A digitizer is a device that captures an analog signal and turns it into a digital signal. An example includes graphic tables, document scanners, and 3D scanners. You see the scanner in your office that you put a paper in and then it scans and provides a physical copy of that physical document inside the computer. That is a digitizer. It basically captures an analog or physical signal and then converts it into digital data, which can be represented within the computer software environment. Another digitizer example is this graphic tablets that you use a kind of pen on to capture motion, then generate a digital copy from that motion. An example is when you go to create your ID cards, there is a particular tablet where they ask you to sign, to put your signature, to sign on, like you use it to insert your signature into the computer. That is what a digitizer is. It captures that physical signal, the analog signals that you're sending in and converts it into digital data, which can be interpreted by the computer. I hope that makes sense. An input device is a device that sends data to a computer. It's very simple and straightforward. Input output, abbreviated as I/O device, is a device that can input data to a computer and accept output data from a computer. We have examples as CD-ROMs, DVD-ROMs, USB flash drives, hard disk drives, network adapters, and Bluetooth adapters. So this is just to let you know that in as much as we have input devices in the industry and we have output devices, there are some devices that have both characteristics. So they are referred to as I/O devices or input and output devices. Moving on, we have a KVM switch. The KVM there signifies keyboard, video, and mouse. It is a switch that allows multiple monitors to use a single keyboard, mouse, and monitor. It allows multiple computers to use a single keyboard, mouse, and monitor. So what we are trying to say here is you could set up your infrastructure in such a way that you have about 5 computers that all interact with a single keyboard, single monitor, and a single mouse. How do you implement that? It is by using a KVM switch. It is a physical device that you purchase and attach to your computer setup. Next, lumen. Lumen is a unit of measurement that indicates an amount of light. So the way you measure how bright something is with using the measurement unit lumen. Next, we do have near field communication or NFC. These days, you go to buy a lot of smart devices or gadgets these days, and you will see NFC enabled, NFC capable. Basically, what is NFC? NFC is a technology that means near field communication, and that stands for near field communication, and means and it's actually a set of communication protocols that allows devices to communicate when they are within 1.6 inches from one another. So basically, it is a technology which enables devices to be able to share data upon touch within a distance of 1.6 inches maximum. So an examples that we see of NFC devices are like this tap and pay phone applications and these interfaces that are found in retail stores, restaurants, and even um, uh, other payment organizations where you can just bring your credit card, touch the interface, bring it close to the device, and it captures some signals and is able to implement payment. So these tap pay applications, a lot of phones that are coming out these days have that ability. So you can simply set up your credit card connected with the phone, and whenever you go somewhere to pay, you can use your phone to tap the NFC enabled device to make a payment. Others that notwithstanding, we also look at an output device, and we basically say that it's a device that is used to send or display data from the computer. So when you've used the input devices to insert data into the computer, and when they have been processed, you definitely need something to display the data that comes out at the end of the day. So we are going to look here at some synonyms, at some examples of all the devices that fall within this category. So for peripheral device types, we have the first category, which says input devices. We have keyboard, mouse, scanners, and a lot more, but we are going to restrain ourselves with these. Next, we have output devices, and examples of output devices that we have are monitor and printers. Monitors and printers are output devices. We equally have projectors and a lot more, but for convenience, we are going to limit ourselves to these few. Input-output devices, as we mentioned earlier, are devices that are capable of both inputting and outputting data at the same time. Examples of these are touchscreen and KVM switch. Remember, they can input data and they can receive data all at the same time. As the touchscreen of your smartphones are enabled to receive input from you, the user, and they equally have a monitor or a screen to display the data that you have inserted and which is processed within your phone's environment. Now, when we look at connection, device connection, the various connection types that we have are USB, FireWire, which are both physical connections, or the wireless connection type. So when you are implementing a peripheral devices and trying to bring them and set them up on particular systems, you have to make sure that they meet some specific system requirements or even hardware requirements to a particular extent. I want to believe that you understand what I mean by system or hardware requirements. These refers to just some specific or minimum, let me just say, system requirements are some conditions that are supposed to be met before something is capable of running within a particular environment. I don't know if you get the point, but I think you should do it if I want to explain hardware requirements. I'll just take this example. They will say, for instance, your graphics card should be at least an NVIDIA 4090i, which is a specific type of graphic card for you to be able to run Zoom. What does that mean? That means when you're connecting this peripheral device on your PC, it should be, before that device runs, that computer must have a specific graphics card, which is at least the NVIDIA RTX 4090i. That's just a specific model. I want to believe that if you have questions, you can ask them, or otherwise the explanation is understood. So basically, when you're done installing your peripheral devices on your computer, generally some of them are plug and play, but in case they are not, the things that you do is you install the software that are supposed to work with them, set up the drivers, and then go to the settings to configure these devices to work as you wish. What is a driver? A driver is basically a software that is installed that permits a particular peripheral device to be able to communicate with an external system. I want to believe that makes sense. So being able to it's just basically a software that permits the firmware of a particular device to be able to communicate with another. So the reason why, if you take a monitor that is produced by Samsung and plug in on a CPU on a central processing unit or computer that is manufactured by Dell, the reason this will work is because there's possibility for you to download the printer drivers from the Samsung website that corresponds to that screen that you get from Samsung, and make sure that it works and install it on the Dell computer so much so to enable this Dell computer to be able to communicate with that monitor. All right. So that being said, that is it for this subsection. We are moving to the second. Do you have any questions? We are taking questions. Do you have any, Mariama? Okay. I'm going to believe that there is no question. So right now we're looking at display devices, and basically they are the devices that we use to like cast the or output the result of computing or processing. So the key terms that we're going to look at inside this section are color depth and resolution. Now, you might be asking yourself, what is color depth or what is even resolution? Color depth refers to the number of bits which is used for each color component of a single pixel. You might not understand the word of multimedia data processing, but I'm just going to summarize it in this way. Let's take the word of images. Images are complex structures that are made up of elements that we refer to pixels. A pixel is made up of bits, which is either zeros or ones. When these elements collaborate in some particular configurations, they can make up a particular color, therefore defining what color a pixel will represent. When we say 7 megapixels, it means there are 7,000 pixels used to represent that a single image. Now, what you get to understand is a color depth refers to the number of bits, zeros and ones, which you use to represent the color of a single pixel. The more, the better. Next, we're looking at resolution. It is the measurement of an image's sharpness and clarity. So the more pixels that make up an image, the higher its quality, and vice versa. Do we have any questions? No, we don't. Okay. So now we move on to the next section where we talk about display, video, and projector troubleshooting. So when you have your output devices that are malfunctioning, how do you troubleshoot them? We are going to look at it in this other submodule. So we have the following key terms that we're going to interact with. That is artifacts, burn-in, codec, video graphics array, or VGA mode. We are going to look at them detailing. An artifact is a part of an image that stays on the screen after the rest of the image has left. So this means there is, you will on your display, this is very much common on liquid crystal displays, where an image will come up, and then when it disappears, or maybe due to electricity seizure, you will see part of that image being displayed on the screen for a couple of seconds before it disappears. That is an artifact. Now, what is a burn-in? It is also known as image retention or IR, but a burn-in is when an image consistently displays on a screen for an image that has consistently been displayed on a screen becomes permanently stuck on that screen, which means that you will now, at the point in time, be able to always see that image like kind of in a blurry manner on top, superposed on every other image that you see on that screen. So assuming that you take a picture of an apple, put it on a monitor, on a liquid crystal display, and leave it there for an extended period of time. When you come later on and then switch to other images, a burn-in, that image that is still going to be displayed of the apple, that kind of looks blurry or dimmed in the background, is what we refer to as a burn-in or image retention. A codec is a file format, basically, and the video graphics array mode, or VGA, is a simplified startup mode that can help you troubleshoot video card issues that interrupt Windows operating system functions. Okay, so when you want to connect a video to the PC, how do you even make sure that the data is being processed properly from the PC for it to be able to be displayed? When your PC processes some information, there is a specific module on your device which is referred to as a graphics card. What is the role of a graphics card or a GPU? Graphics processing unit simply processes images or elements to be displayed as outputs. So for your monitor to be able to interpret what the process the CPU has worked on, there is need for the GPU to process that information first. So the GPU is that which plugs into the motherboard and taps the data from process data from the CPU, then does its own little mathematics on it, and then transmit it to the monitor or the other display devices through VGA, DVI, HDMI, or any other type of cable that applies. Now, when you turn on your how do you even troubleshoot an instance where, for instance, there is no image displayed on your monitor? The things you have to figure out there, you ask yourself a couple of questions, starting with, is the computer even on? When if you tick that box, you have to find out if the monitor is on. If the monitor is on yet it's still displaying nothing, make sure that the monitor is connected to the video that is being sent from the computer. Now, you also have to make sure that your PC is not in power safe mode, because there is this mode which puts your computer to sleep basically when it stays for an extended period of time without any interaction. Make sure that the monitor's power supply has not failed, or the video card or the video card or GPU has not been damaged equally. If you're as well unable to transmit data from the computer to the monitor, you should also verify whether your video cable has a problem or the video card or the GPU is properly seated on the motherboard. So these are some of the things that you should consider doing, asking yourself and verifying in an attempt to troubleshoot a scenario where your monitor displays no image. So you should always make sure to test your video components across PCs. Now, your video board or graphics card can undergo certain damage, a lot of damages. Like some of them are barely visible. Within the early modules of this course, we talked about electrostatic discharge, which is a particular type of electricity that accumulates in someone's body as they move around, and it's actually requires a very small amount to damage electrical components. So given that these video boards are made up of very small or microprocessors, ESD is a great challenge, or it's a great threat to the security or stability of these devices. Now, if the video board or the GPU is not properly seated or properly secured, clipped in on the motherboard, it poses a challenge. So some of the reasons why a video cable will not work would be that it is incompatible. The connectors that you have used are not compatible with each other. The cable might be damaged, or some of the connectors are damaged. Now, when you use VGA mode, all right, it is basically a scenario where you are telling your computer that, oh, something is malfunctioning. I want to turn my computer in a way that it is going to replace all the drivers that are missing and prevent any third-party software from running, but make sure that the basic necessary ones are working enough. So there you'll be able to turn on your PC and see the video. Your PC might as well shut down due to excessive heat. So you should always make sure that you control the temperature in the room where the PC is and keep the cooling vents clear. Due to accumulation of dust in some PCs, the cooling vents are stuffed with dust or dirt particles that prevents proper circulation of air, thus causing overheating and thermal shutdown eventually. Color calibration, right, is just setting up your monitor to a particular level where the color or the display that it performs is the displaying capabilities actually suit your taste. So you should consider using the native resolution of that monitor. So if your monitor is 720p, you should not use 1080p. It is going to display, but it's not going to be perfect. It's not going to be the best. So say, for instance, you go to YouTube and you need to play a video. If you go and play a 1080p video on a 4K screen, you are actually underutilizing the capabilities of your resources. But if you go and play a 4K video on a 1080p screen, you are basically overutilizing the resources and you will not be able to maximize the output from it. Next, set the color depth to 32 bits. We looked at this. Work at an operating temperature. So make sure that the temperature around you is okay for devices to function. It shouldn't be too hot nor too cold, just balance. Print out a color image and then match prints and monitor. Make sure that the image that you have printed matches what is displayed on the monitor. If the issue that you're experiencing is a dim image, like your screen is just very blurred, it means that some your brightness settings are not properly set up. And if your brightness settings are not properly set up, the screen will appear to be very dark. Now, it could also be that the backlight inside your PC is or inverter, sorry, they are not is not providing enough light. So it is going to cause a scenario where your PC does not display clearly. So some of the backlight could have burnt out, or the inverter is malfunctioning. The inverter is basically the lights behind the screen that display. Okay. That if your image is flickering, what do we mean by flickering? Like showing lines appearing and disappearing constantly, like really with short intervals, just doing a lot of on and off. That means your CFL could be failing, or the inverter as well could be failing. So those are things you should consider replacing. One of the things you should also do is to align. If you have several monitors connected, you should make sure that they are properly aligned. Properly aligning prevents you from being able to from losing part of your data or from improper configuration. So when you align properly, what you're supposed to display on one screen is displayed perfectly on the other screen if they both have the perfect or matching screen alignment. Now, if a pixel is dead or is stuck, Some of the things that you can do to solve them is by applying slight finger pressure on the screen or using a software to redo the whole thing. Now, that is it for these liquid crystal displays, or sorry, LED screens. And now we're going to look at projector troubleshooting. A projector is basically a device that outputs data by emitting light signals that can display data in an arranged manner on the screen, on a particular screen. So we're going to look now at how you when you set up a projector, you have to make it in an environment that is not well lit, that is kind of dark, having the appropriate height to make sure that you maximize the output or the capacities of this projector. Make sure the environment does not have too much light. It should be dark enough. A dark room is preferable. And then it should be displaying on a white surface. Now, if for some reasons your image is foggy or blurry, make sure that you can use a compressed air to dust the interior of the PC, because any other thing might damage even more components, because the projector components happen to be just so fragile. So sometimes your projector might die and it might just be shutting down. So some things that you can manage to resolve this is by setting the corresponding resolution. So make sure that the projector is displaying at the same resolution as that which is providing the data from the source. You should clean or replace the LCD panels, update the projector drivers and softwares, check the standby mode, make sure that it's not in standby mode, and verify the indicator lights. Generally, these indicator lights tell you what the state of the PC, and you don't always need to, of the projector, sorry, and you must not always carry out complex troubleshooting. Just by observing the lights can give you a lot of information. Okay, so your projector could also have audio issues. You have to just make sure that the computer audio output is pointing to the projector. You update the projector applications, those that manage to configure it, convert VGA to HDMI, because we all manage to, because VGA does not transmit audio, but HDMI does, all right? High definition multimedia interface. So because of the multimedia aspect of HDMI, it can transmit both video and audio. It is just the VGI that is capable of some VGI cables are capable of transmitting both audio and video at high quality or display ports, but HDMI does that HDMI does that best. Also select audio delay function to make sure that it is properly synchronized with the PC. So summarily, we've looked at physical issues that might come up with the displays, the display issues, unexpected shutdowns, and how you attempt or address audio problems. Do we have any questions? Okay, no question. Now we're looking at device driver management. We talked already about what a driver is, and basically device driver management is just a utility that permits us to be able to manage all the drivers that are installed on our PC for every peripheral devices. Okay, so that being said, when you're going to cover this section, you're going to understand, you're going to go through how you install and manage device drivers on Windows, how you manage devices on Linux and on Mac OS or Macintosh operating system. Now, sometimes you're going to use it as direct memory access or DMA, a driver, hot swappable device, interrupt request, input output address, or IO address. Now, let's look at the definition of these concepts. DMA conduits are conduits used by high-speed devices to bypass the CPU and communicate directly with the RAM. Direct memory access is a conduit that is used by high-speed devices to bypass the CPU and communicate directly with the RAM. I don't know if that makes sense. So there are some devices that need extremely high speed of functionality. So instead of going through the CPU and following all the complex processes that are involved and lengthy processes, they just communicate directly with the RAM and get the data that they need. So that is referred to as DMA, direct memory access. A driver is a program that enables the operating systems to interact with hardware devices. Okay, so when you plug in a different hardware device on a particular system, it's a driver that is going to tell the operating system that, oh, see, this is my language. This is how I this is how I operate. Then the operating system will be able to communicate with that device. A hot swappable device is a device that can be added and removed without shutting down the computer. For example, thumb drives are hot swappable. Thumb drives, flash drives, USB drives, all of them basically mean the same in our uh, local expressions. So is when you say device is hot swappable, it simply means that while your computer is turned on, you can plug that device and unplug it, and it functions just fine without having to turn off your PC. Remember those days where smartphones, for instance, you had to always turn them off, put a SIM, and then turn them on before it can read a SIM card. But these days, we now have hot swappable SIM slots, which means while the phone is on, you could easily plug in, put a new SIM, insert a new SIM, and remove it without having to restart or power off your device. That's what hot swappable stands for. An interrupt request, or IRQ, is a communication method that allows a device to interrupt the CPU and request processing time. Okay. So RIQ is like an interrupt, basically scenario where the CPU has to stop everything that it's doing to attend to a particular case on the process, which is kind of higher priority. So IRQ is a request that is going to uh, send a particular interrupt to the CPU and ask for processing time for something for a particular reason. So input output address is a data address that allows two devices in the computer to send information to each other. I believe that is pretty much straight to the point. Okay. So we're looking at device drivers. Operating systems have some default drivers. Some drivers need to be installed by the administrator. Other operating systems, some drivers are specific to some operating systems and specific to some hardwares. Every driver has a digital signature, and you must always keep your drivers up to date. So basically, when we've talked about device compatibility, plug and play devices, legacy devices, installing drivers, hot swappable devices, and safely removing hardware. So you're going to go through this chapter again on the platform, and you carry out labs and exams that are going to permit you to better master all these scenarios. That being said, we go to device driver troubleshooting. Now, these are the problems that you're going to face when your PC can no longer recognize some certain hardwares that are plugged into it. So there are kind of some things that you could do in order to make the device to work again. The main concept that we're going to talk of here is rollback. It's basically reverting the state of a system, going back to a previous state that was still functioning properly. Let's say something. Let's assume that you have a blue card today and everybody likes you. You go, you sell that blue card, or you change that blue card to black. Now everybody hates you. How do you fix this problem? What you do is you simply go back to the color or the state where everyone liked you. So it's kind of a weird example, but basically it's an analogy for you to understand the concept of rolling back. So it is a state where where you revert a system that has received an update or another change to its previous state. We just explained that. Now, when you're troubleshooting devices that are plugged into the PC that are not working as they're intended to, what are some of the things that you're supposed to do to make sure that to troubleshoot this are verify the cable connections, make sure that the cables are properly connected, check the power connections and make sure that power is being provided to these devices, and make sure that all the cards are seated and secured properly. Go to the BIOS of your PC, like boot into the BIOS, and then verify that these devices are first of all recognized in the BIOS, because if they are not recognized in the BIOS, you'll not be able to recognize them inside your operating system. Because BIOS stands basically it stands for the basic input output system, and it carries out some a series of tests that we refer to as post test to verify whether all the input output devices are working properly before the device your operating system turns on. So the BIOS should be able to identify these devices. If to an extent that does not work, another thing that you can do is to go to the device manager, which is a software in the Windows operating system that permits you to view every device that is on your PC, their current state, their drivers, their signatures, and even the permission for you to update these devices. If you see a gray arrow on the device, unfortunately, we don't have the device. We don't have that available here. I think we are going to demonstrate. But if you see a gray arrow on a device, it means that device is disabled. If you see a yellow triangle with an exclamation mark within, it means the device is not working properly. If you see a yellow question mark, it means the device has been detected, but the driver has not been loaded. So those are some of the ways that you determine what is the issue with a particular device that is not working properly. Now, reverting the system means that you roll back the driver. You uninstall the device, then reinstall it. It goes back to the previous state, or you use your restore points. That's why it is essential for you to always do restore points on your PC. So basically, we have looked at the basics of troubleshooting, verifying that the device shows up in the BIOS, verify that it shows up in the device manager, and always test with a known good spare. Basically, that's it for chapter 10. That's just it with chapter 10. It's a summary explanation of what you're going to be looking at in the chapter. So you're incited to go onto the platform and look at it, give it a look to be able to determine how you actually implement all of this physically. I'll just share real quick the device manager and show you the state of some of the devices on my PC. So let me just look at, okay, device manager is open. It's opening. So we're going to show you how you identify devices and the technical issues that they might be displaying, they might be experiencing, and also how you address these issues. Good. Okay. Okay. The device manager has shown up. So basically, you're going to drag it this way. So I believe you got, okay. You can see the device manager now. So this is the software in Windows that we call device manager. You can see here, it is showing all the devices that are available for this user account. If you look at audio and input, it's going to show all the audio and input devices connected to this PC. There are three microphones and audio input and output. There are three microphones available, and there is one speaker. If you look at battery, same thing. There is And a Microsoft AC adapter, the Microsoft ACPI compliant control method battery. There is, if you look at camera, it's just a software camo that manages the camera module. You look at the computer, it has basically an interface to display the monitor of this PC. The disk drives is going to show all the hard drives that are connected to this computer. If you also look at the display adapters, if you look here at the display adapters, you're going to see that I have the Intel R HD Graphics 400. It is basically a GPU, a graphics processing unit, but it's an integrated GPU, all right? Unlike the external GPUs that we know that you have to insert first into your computer, the the Intel R HD graphics, or most GPUs that come in slim laptops these days, in laptops, sorry, are integrated GPUs, which means that they are integrated inside the CPU chip. They are not separate modules. Okay, we can see we're not going to look at all of them, but basically these are all of the this is how the device manager, this is how the device manager looks like, and how you can troubleshoot stuff. Look at the red triangle that we talked about here. What did we say the red triangle stood for again? We did say that the red triangle stood for, sorry. Okay. So we said the red triangle, a yellow triangle with, sorry, trying to pull this up. Okay. So you can see now. No, yes, no. Okay. If you look at this yellow triangle here, it says that yellow triangle with an exclamation mark inside. Yellow triangle with an exclamation mark means the device is not working properly. So the PCI symbol communication controller on my PC is not working properly. If you see just a question mark, if you see just a question mark, it means the device has been detected, but no driver has been loaded. Look here, you will see here a question mark. This could be any device, it could be anyone, right? It could be any single device on your PC. That's how you manage to troubleshoot your computer. You can see right here that I have an Intel R Core TM i5 processor with a 2.60 gigahertz, and it's a 4-core processor. That's why you see 4 different cores here. So you could do that on your PC and look at it on a deeper level. So basically that's it for chapter 10. We are done. Do we have any questions before we take a break and then start with chapter 11? Do we have any questions? Nabila, welcome to your late.
God. Thank you, sir.
Why are you late?
I'm on my way home. I'm almost getting to the house and the place is quiet. So I just decided to be listening to the voice while I'm moving home instead of wasting the time.
Okay, so basically after today's session, we are going to have just 4 more sessions and that will be it. We have 4 more sessions and we'll be done. 4 more.
Okay.
Yes. So less than a month, that's a month already. So we might even finish faster. So I'm just including this the exercise, the revision aspect of it, but nonetheless, it should be at least 3 weeks, and we are done with the whole thing. Okay. All right. So this is it. We are starting with networking. We're starting with networking, and yeah, we're just going to do a quick rundown, a quick overview. The networking is because it's kind of broad. Networking is kind of broad, but because you have access to the resources on the platform, I'm just going to introduce you to the key concepts, and then you can follow up on the platform for more insight. So we are going to take a 10 minutes break. It's currently 30 minutes past 8. So at exactly 23 minutes past 8, we are going to pick up and continue from there. So that will be networking. See you guys in 10 minutes. Oh, okay. Are you there, Cynthia? Cynthia, are you there? Okay, so there's a software that you guys are going to have to install on your computers before we carry on with this networking chapter. So that software is called Cisco Packet Tracer. So basically, we're going to just look at like a summary of this the whole networking concept. And during our next session, we're going to start with exploring Cisco Packet Tracer for continuing with the next things that we have to do. It is very important if you're willing to understand networking and the concepts around it, how to interconnect devices, then you should perform that. Actually, this is an assignment. Go ahead during the week, you install Cisco Packet Tracer. And when you do install Cisco Packet Tracer, we should look at it. We should look at all the other concepts during our next session. So we're just going to go ahead and have a brief introduction of what networking is, networking devices, networking technologies, and the concepts that apply around it. So some of these are the terms that you're going to interact with as we start talking about networking. All right. So that being said, yeah. So let's look at these key terms and their definitions. We're just going to get these definitions real quick, and that is going to be it for the day. So starting with the first thing, what is a network? A network is basically a group of interconnected computers and devices that can share information with each other. Okay, so any setup where you have several computers, two or more, that can share information with each other, that is a network. A subnet, on the other hand, is a portion of a network with a common network address. So when you have a particular network IP address for a network, and then you split that network into two halves, each of these networks are referred to as subnets, but all of them make up a whole, all right? It's just as males and females make up human beings. That's just it, like a set. 1 and 2, 3, they make up a set of numbers. So that's just what we're talking about here. Nodes or host are devices that reside on the network. Hosts can range from a computer, a tablet, mobile phone, gaming console, IoT device, or server. A transmission media is a medium that is used to carry electrical or radio signals between connected networks hosts. So how you transmit data between the various hosts on a network is referred to as transmission media. What means you use to carry on with the transmission. So we also look at network interfaces, which are interfaces that refer to those interfaces that convert digital network data into a signal that can be transmitted along the transmission medium. So if we have a wireless transmission medium, a network interface for the wireless transmission medium will be set up to transmit that. If we have a wire transmission medium, a network interface card will be set up to transmit data in the appropriate format. Okay. So the next thing is protocols. Okay. All right. So we're talking about protocols. We're talking about protocols, and we refer to them as those set of rules or standards that describe how a host or nodes in the network can communicate and exchange data. So the set of rules that manage data transmission between among hosts of a network are referred to as protocols. So peer-to-peer is in a network in which a host can both share and access data. So on some networks, some people can only send, on others, some others can only receive. But in the peer-to-peer environment, you can both send and receive all at the same time. The client-server architecture is a network in which hosts have specific roles. If you look at the storage attached network, it's a special type of network that provides high-speed access to storage across the network. Specialized hardware is used to store and provide access to the needed data. So it's basically a means of implementing a storage device that is on the network, which everybody can find. So a body area network, or BAN, is a network. It's a very small network that consists of wearable or implanted devices such as smartwatches, fitness tracker, or medical implants. A lot of you might not know about BAN, but yes, there is something like BAN. It does exist. Okay, there is also PAN. You should have heard of that, personal area network. And it's a small network for communication between personal devices such as wireless earbuds and cell phones. Good. So that being said, we should look at a LAN. A LAN stands for local area network, and it's a network in a small geographic area like an office. A LAN typically uses wires to connect systems together, okay? So it could also be a wireless LAN, basically a network in a small geographic area like an office, but that uses wireless connections to interconnect devices. A campus area network is not very much different from LAN, but it's just a corporate area network established where multiple LANs are connected within a limited area, such as a college campus or between multiple buildings that are owned by the same organization. You might know of metropolitan area network, wide area network, wireless mesh network, wireless wide area network, and so on and so forth. You are going to be provided with these resources at the end, and you can study it further equally with the resources that you have on the Lapsim platform. All right. So an internetwork is a network which geographically dispersed connections that connect multiple LANs. So if you have LANs, several LANs in various areas of the world that are interconnected to each other, they make up the internetwork. But some people will refer to it as the internet. So it just depends on whether it is accessible or not. These little concepts are those which permit you to be able to distinguish what an internetwork is, an internet, intranet, and extranet. An internet, on the other hand, is just a large worldwide public network accessible to everybody or by everybody. An intranet, on the other hand, is a private network that uses internet technologies, while extranet is a private network that uses internet technologies, but its resources are made available only to trusted external users. For example, customers or stakeholders of the company. So if you have a network, local network that people can access from the entity from the outside, but they have specific privileges that makes you have an extranet, but an intranet will only be one that is for within the organization. So basically, we have covered all these concepts. We've already looked at the key concepts here. While you are going to be downloading the packet tracer that we just talked about, if you have issues downloading and setting it up, let us know and we're going to help you through. So it's called Packet Tracer, Cisco Packet Tracer. It is a software that simulates networking environments, all right? Cisco Packet Tracer. Download and install. Cisco Packet Tracer. Okay, good. So that being said, I guess we should be calling this a day. We're going to leave you this additional time to use it for your for yourself, on yourself, use it to work more on yourself, work more on the task that you've been given. We're going to try to have one day within the week to look at the Cisco packet tracer, because it's not actually within our curriculum. We are just including it so that you can have a better experience when you step out there. So that should be it. We are basically done with our session for today. So yeah. Do we have any questions? All right, no questions. So that should be it. You all should have a nice, happy new week, and study well. We'll make sure to ensure that you guys are doing that and good. So that should be it. You all should have a great week.